Good evening, class. My name is Jonathan Rose, and this is my submission for the Interactive Advanced Concept Presentation number 6. And today we're going to be making a pasta rocket. So today, the supplies that you'll need for this experiment are hydrogen peroxide. You'll need some yeast, which I happen to pour out into a container here. This is about a tablespoon. You'll need a mason jar with a hole cut in the lid, and you'll also need a tubular type of needle. ZD, or in this case I used rigatoni, would work. And you'll also need a lighter. So we can go ahead and get our experiment going. As I mentioned, you're going to need to go ahead and put your tubular pasta noodle into the hole that you created in your lid. We'll go ahead and take that off, and we'll go ahead and fill half of the mason jar with hydrogen peroxide. Okay. And then we'll put our tablespoon of yeast into our hydrogen peroxide, and we'll give it a good mix. Okay, we'll put the lid on. We'll give it a good mix. The bubble's starting to form. Whoop. Whoop. Okay. And we'll go ahead and we'll light our pasta. See? And there we have it. We have our pasta rocket. We'll go ahead and let that burn. You want to make sure that you're holding onto the lid because you don't want the lid to go ahead and pop off. As you can see, we kind of made a little bit of a mess here, but our pasta rocket is still going. And if I were to go ahead and take the lid off of our oxygen source, our pasta rocket should stop. See? And that's our pasta rocket. So that was our pasta rocket experiment in which we had hydrogen peroxide and we mixed that with yeast. Now we'll go ahead and we'll do the negative control portion of our experiment, where we will go ahead and perform the same experiment, except the only difference with this control is that we're only going to have hydrogen peroxide and we are not going to be adding the yeast component. So again, here's the same mason jar with the hole on top. We have our rigatoni noodle, or ziti, or any tubular type of pasta in the hole. We will go ahead and add our hydrogen peroxide. Okay. And because this is the negative control of our experiment and we're not adding the yeast, we can hypothesize that if I were to hold a flame above the noodle, it would not ignite like it did in our experimental portion of this experiment. It won't be creating a pasta rocket. So here we go. So as you can see, it's not really igniting at all like it was when we had the yeast component added. All it's doing is really just burning my pasta noodle, but it's not igniting and forming a pasta rocket And we will be explaining why we are seeing the pasta rocket and why we're not seeing the pasta rocket right now with our control in the next portion of this video. So what did we see in our pasta rocket experiment? The pasta noodle acted as our solid fuel source, while the oxygen from the hydrogen peroxide acted as our gas oxidizer, which reacts with the flammable or combustible materials, which is our flame from the lighter. Adding yeast, which is a catalyst to the hydrogen peroxide, helped speed up the production of oxygen and water, as provided by the equation below. As you can see by our picture here, the hydrogen peroxide is held together by 3 single bonds and is considered to be covalent. When the yeast was added to catalyze the production of water and oxygen, the chemical bond holding that oxygen atom to the hydrogen peroxide was broken, thus leading to our products. Water, which is held together by 2 single bonds, and oxygen gas, which is held together by a double bond. The bubbles we see being formed inside our mason jar is actually that oxygen being released from the hydrogen peroxide. As oxygen is being released from the hydrogen peroxide, heat is also being produced, since this is an exothermic reaction. Remember, oxygen is our oxidizer, which makes it flammable. Then we have our pasta noodle, which is a complex carbohydrate and contains hydrocarbons. This acts as our source of fuel. When our pasta noodle was in the presence of oxygen being released, when we finally added the lighter, a combustion reaction occurs in which heat was released. This led to our pasta rocket being ignited and being pushed through our tubular noodle, which we see here. Then, once either the oxygen stops being produced or our fuel source, the pasta noodle, has all been burned or used up, the pasta rocket flame stops. So now we'll talk about the negative control portion of our experiment. During this negative control portion, we excluded the yeast component. Therefore, there was no catalyst to help speed up the production of water and oxygen. Since oxygen wasn't being readily produced, there was nothing to act as an oxidizer, which remember is flammable. Therefore, our pasta rocket did not ignite when we added our flame. It would be interesting to see this experiment occur on a much larger scale. This is another one that is great for kids and shows us a very basic idea of how chemical reactions can be used to create a rocket. Again, my name is Jonathan Rose, and this is my submission for the Interactive Advanced Concept Presentation number 6, and thank you for watching.